All right, everybody, now we're moving on to Investigation 5A, which has a lot to do with what are called frontal passages. So if you've ever been outside on a nice warm day and then suddenly the temperature drops substantially, chances are one of the possible reasons is that a front has passed through. I actually experienced the frontal passage one time, and I'll actually shoot another video for another time and show it. I always love to include that frontal passage data in one of my classes. Who knows, you may see it on the next quiz, you may not. But with that said, this investigation deals with frontal passages. So the goals in this investigation are first to understand how air pressure changes horizontally as a weather system travels. And so when we talk about air pressure changing, typically we talk about it changing vertically. As you rise in the atmosphere, air pressure declines. But for this module, we're going to talk about the horizontal changes in air pressure, and specifically how they relate to weather systems such as cold fronts. Then the second thing we're going to do in this example, or in this investigation, is we're going to talk about what are called mediograms, and I'll show you how to read them, and they're not that bad. And then finally, using a mediogram and the weather data plotted on it, we're going to then talk about how to identify the passage of a cold front. One of the things I'll say before moving ahead is that this particular investigation does a really good job of walking you through the process of identifying a frontal passage. With that said, the first few questions of the application section build on Investigation 4, and then Investigations 4A and 4B. So you're going to see things about advection again. You're going to see things about rotation around high and low pressure systems and how that relates to warm and cold air advection. So definitely make sure that you're still a little aware of what was covered in Investigation 4A and 4B. And if you do that, you should be just fine. Okay. So the very first diagram that they show on this particular investigation is this diagram right here. And so here's what's going on. You have two high pressure systems, both marked with these H's. And to be honest with you, typically in the wonderful world of weather, we usually denote high pressure with a blue H. So I don't know why this one's labeled red, but just it's a high pressure system. And the idea is how is air pressure changing as you're traveling from one location to another in the setup? Well, if you recall from a few investigations ago, if I recall this was Investigation 2A, as you depart a high pressure system, like this one right here, your pressure should be declining. You should be getting lower pressure and lower pressure and lower pressure. Now at some point, you're going to be approaching the second high pressure system, and so your air pressure would be going up. Now with that said, in between these two high pressure systems, we have this blue line here. It's more like a dark blue, purplish line. And you notice this spike here. This actually indicates a cold front. And cold fronts actually represent an area of lowest pressure. So this area right here is basically a low pressure. And in fact, I'll even pull out my handy dandy pin here. And this is a low pressure right there. And so the idea is that as this front is moving, and typically these fronts move in the same direction that the spike is pointed in, so this front is moving in this direction. Let's say I was located here. I'll actually I'll draw myself here next to the thing that says warm air. But let's say I am right over here. Well, what's actually happening is, and there's my little smiley face, there we go. And what's actually happening is this cold front is approaching me. And as the cold front approaches me, pressure should decline. And then once the cold front arrives and then passes, pressure will then begin to increase as this high pressure system over here is now approaching me. So that's the first thing you really notice with the frontal passage is prior to the front passing, pressure declines. Then once the front has passed, pressure then goes back up. The other thing that you'll notice when a front passes is depending on the type of front, and really for today's activity, we're only going to deal with cold fronts. And they're typically the most blatant, so typically what happens, and in fact more than typically, what happens is ahead of the front, so I'm still ahead of the front has not reached me yet, I'm in a layer of warm air. Well, what happens is as this cold front approaches, it pushes the warm air out of the way and moves cold air in. So what's actually going to happen is once this cold front passes me, the warm air will have been pushed away, and now I will be in an area of cold air. And so really, a few telltale signs for identifying a frontal passage are a sudden decrease, bottoming out, and then increase in air pressure, and a sudden, sometimes even sharp, decrease in air temperature. And I'll actually show this to you in a few minutes when I show you a Mediagram. So the next thing in the application section, they have you look at a map of the United States, and they particularly have you look at Little Rock, Arkansas. And Little Rock, Arkansas is a city in central Arkansas. It's actually the only one with a station model. And I can't give you a whole lot of answers about it, but we're actually going to be looking at a Mediagram for Little Rock, Arkansas in that particular activity. With that said, I've actually taken a Mediagram from several activities back, from several versions of this lab book back, and I've put it right here, and let me talk about it a little bit. So the purpose of a Mediagram is rather than looking at many different locations at a given time, we're now looking at just a single time. Now we're just looking at a single location, but now we're looking at a longer period of time. Mediograms plot weather data for a location over a 24-hour time period. And the one I have right here, this is for Mobile, Alabama, MOB, and this was taken on February 26th, 2018, so about a year ago, from when I'm recording this video. And then this right here actually mentions the start time. This was 0 UTC to February 27th, 2018 at 0 UTC. And here's what's going on. In the upper panel, the red line represents air temperature, and the green line represents dew point. And air temperature will always be either higher or equal to dew point. It'll never be lower than dew point. And so that's pretty self-explanatory. I don't think there's a lot that needs to be explained there. The next thing that we look at is sky cover, wind direction, and wind speed. And these work exactly the same as the station model on any weather map. So if you were comfortable with Investigation 2A and you feel good with the station model, this is just that. There's no real big difference. This third panel shows visibility and precipitation. And we're not going to really deal with visibility a whole lot in this particular assignment. We may talk a few seconds about precipitation, but we're not really going to worry about visibility. And precipitation, they just throw on the same symbols that they do with the station model. So in this case, you see the 2 green dots, that represents light rain. Here you have 4 green dots, that represents heavy rain. And then over here, these equal signs, those represent fog. And again, we're not going to really go too into depth about that. But this final panel, this is one of the 2 biggest panels I want you to look at. This actually shows you mean sea level pressure, so PMSL. It doesn't mean pumpkin, something with an M, spice latte. No, it means pressure mean sea level. Basically, we take the recorded pressure at a location and calibrate it to sea level. And this shows you how that mean sea level pressure changes. And then the last thing I want you to see here is what these values down here represent. So this is actually a date and timestamp. So this first number right here to the left of the / is the 26th. That's the date of the month. So this Mediagram was taken on February 26th, so this was the 26th. And then the second here on the right side of the / is the time in UTC. And remember, UTC is the time at Greenwich, England. It's the universal time coordinate we in the wonderful world of weather use. Now, one of the things I'll mention is that you'll see those times mentioned a few times in this lab activity, but they usually do a good job of translating it for you, telling you, okay, this is what it is local time. But wherever you see 00Z or 02Z or 03C, they're just talking about universal time. All right, now let me show you how to actually interpret this to then figure out when did a front pass. And it's actually not too difficult. So buckle in and here we go, let's do it. Okay, so when we want to look for a cold front passage, here's what we want to look for. First and foremost, we want to look for a sudden drop in temperature and or dew point, usually both. Sometimes one may not respond as much as the other. Sometimes one will respond more drastically than the other. But if you take a look, in this case, so this was at 0Z, pretty much between 0Z and 8Z, temperature was remaining relatively constant. It kind of ticked up a little bit, and then right at about 8Z, temperature dropped noticeably in the next 2 hours. That is a telltale sign that a cold front has passed. Why? Because once a cold front has passed, you have now transitioned from a warm air mass to a cool air mass, and therefore you get a nice decline in temperatures. So that's something that you're going to look for in today's activity. You're going to look for a drop in temperature and or dew point. And they'll actually have you determine how much it is. And they do a really good job of not choosing between two very close numbers. They usually give you a pretty good, the correct one usually is very different from all the other ones. So for example, here, the temperature I'd say the temperature at 8Z was 68, and then the temperature at 10Z was 60. So that's an 8-degree drop. So they're going to ask for something like that. And on the question, they would ask 1 degree drop, 8 degrees drop, 18 degrees drop, or 28 degrees drop. So they're not going to ask you 6 degrees, 7 degrees, 8 degrees. They're not going to do that to you. So, and you're going to do the same thing for dew point. The second thing that you're going to look at is a sudden shift in the wind direction. And there's actually a pretty textbook way that meteorologists look at this. Typically, when you're in a warm air mass, the wind has somewhat of a southerly component. Why? Because warm air is being blown, and warm air typically comes from the south, here in the northern hemisphere. And then typically, once the front passes, you'll get a shift to either west, northwest, or north. It'll have a strong westerly and northerly component to it. And you'll see something just like that in this particular activity. With that said, look for a situation where the winds were relatively coming out of the same direction, and then all of a sudden they pulled an almost opposite turn on you. That's a really good textbook example of a cold front passage. The third thing, though, we typically kind of only look at this if all else fails, is the passage of precipitation. Usually as a front pass or as a front approaches, you get buildup in cloud cover, but not really any precipitation until just a few hours before the front arrives. Then you get rain or snow depending on how cold it is, or you may get thunderstorms, you get some kind of precipitation. And then a few hours after the front is passed, the precipitation goes away. So one thing that we'll look at, again, when all else fails, is when you have some kind of precipitation. And then the final thing that we want to look at is, and I mentioned this earlier, for air pressure to bottom out and then to begin to rise. So again, in this case, air pressure was, if you actually take a look at the beginning of our period, air pressure was declining. It was at 1019, it declined to 1016, and then after the front passed, it then jumped up to 1023. So it went from 1016 to 1023. That's a 7 millibar increase in air pressure in, actually, let's see here, so this was 9Z, that's what I'm looking at, so this right here was right around 9Z, so like right after. And sometimes one of these will actually, you won't see the shift until an hour before or after the front passes. But it gives you a pretty good indication of when the front passes. But yeah, we went from there, so 9Z to 15 hours later, we rose 7 millibars. Believe it or not, that's actually a pretty noticeable pressure increase. That's actually something that meteorologists take note of.